Welcome to This Explainer. Today we're diving into an absolutely fascinating approach to engineering project management. We're going to break down SharpBrain's highly opinionated repository-based ticketing system. This is a framework that takes traditional project management and literally flips it on its head by treating project plans exactly like code.
All right, let's kick things off with a universal developer frustration, right? Why is it that the project plan always seems to drift from the actual code? If you've spent any time working in software, you know this exact pain. You've got a tracker that says one thing, while the actual codebase is off doing something entirely different. And the worst part? Nobody even notices for 3 months. The plan and the reality end up living in two completely different worlds.
Well, SharpBrain solves this drift by introducing a massive paradigm shift. So instead of relying on a traditional tracker, like Jira or Linear, which inevitably drifts from the code and makes you use a separate login, SharpBrain just puts its entire backlog in YAML files directly inside the repository. It is strictly version controlled, and amazingly, it's machine validated.
Okay, here's our structured roadmap for this explainer. We've got Section 1, the plan lives in code. 2, anatomy of the backlog. 3, reading a SharpBrain ticket. 4, the developer workflow. And finally, 5, tooling and guardrails. Let's get right into it.
Section 1. The plan lives in code. Why the backlog actually belongs in the repository.
Let's start with the core philosophy here and the why behind this radical approach. Moving the backlog into the repository brings 4 incredible benefits to the table. First off, the plan is reviewed exactly like code. Changing a ticket scope? That means opening a pull request. So scope doesn't just quietly expand by Friday afternoon, it leaves a solid paper trail with an approver's name attached. Second, the plan travels with the branch. If you check out a branch from 6 months ago, you get the tickets exactly as they were understood back then, giving you perfect historical context. Third, it's machine checkable. Scripts can literally run through and validate your project plan. And fourth, it's readable by everyone and everything, no login required. A new engineer or, hey, even an AI coding agent can read the entire backlog instantly, right there in their editor.
Moving along to Section 2, anatomy of the backlog. Breaking down phases, epics, and tickets.
So how is all this YAML organized so it doesn't turn into a total mess? The backlog operates on 3 strict levels, moving from broad project themes all the way down to highly specific deliverables. First up, we have phases, numbered 0 through 6. Now, what's crucial to understand here is that phases are an ordering, not a deadline. They just answer one simple question: can I start this yet? Next, we have epics, like Epic 14. These group together related work tied to a single outcome. And finally, we drill down to tickets, like SB 1403. A ticket is just one deliverable, owned by one person, and closed by a single pull request.
Now, every epic has a stated goal, and this brilliantly illustrates how a single epic goal acts as the ultimate tiebreaker. This quote here is the goal for Epic 14, which is AI grading. Notice how it doesn't just describe a feature, it describes a concrete change in a user's life, along with a strict constraint. When an engineer is deep in the weeds of a ticket and they're unsure if a certain edge case matters, they just look back at this sentence. If a coding decision makes the sentence less true, well, it's immediately the wrong decision. It's a fantastic guiding light.
Section 3. Reading a SharpBrain ticket. The strict anatomy of a single deliverable.
Let's see how all of this builds into the anatomy of an individual deliverable where literally every single YAML field is doing heavy lifting. Tickets come in standard t-shirt sizes: extra small, small, medium, large, and extra large. But wait, there is a massive contrarian catch here. XL does not mean a large task. It is actually a hard stop sign. If a ticket is marked XL, it means it is absolutely not ready to be worked on. It's telling the engineer to stop, step away from the keyboard, and book a grooming session immediately to break it apart before writing any code.
Then, we get to the acceptance criteria. And the crucial point here is that vague statements are outright banned. You cannot write "works correctly" or "handles errors gracefully." No way. Every single line has to be an observable, testable contract. For example, a proper criterion would be something like, a 2 GB upload resumes after a network interruption without resending completed parts. 2 people can look at a running system and instantly agree if that is true or false.
That brings us to Section 4, the developer workflow, the daily repeatable loop.
How does an engineer actually interact with this system on, say, a random Tuesday morning? Well, the first half of the developer loop focuses purely on preparation.
Step 1 is to pick a ticket from the generated board that has absolutely no open dependencies, because working out of order is exactly how you end up building against a shifting foundation. Step 2 is reading and resolving any ambiguity on day 1 to dodge a costly rewrite later. Step 3, you create a branch using a very strict identifier format. And Step 4 is critical. Contract first. You must update the schema in the shared contract before touching the implementation. Honestly, doing this backwards is the #1 way to block downstream work for your front-end teams.
The second half covers building and shipping. You build and you test, putting a huge emphasis on non-negotiable tests, like tenant isolation, making absolutely sure a query returns nothing for a different tenant. You commit your code with the permanent ticket ID securely in the footer, which is enforced by a commit hook. Then, you open a single pull request that actually requires an honest rollback plan. Finally, before you even ask for a review, you have to walk the strict definition of done.
And speaking of that definition of done, there are a few strict rules here that tend to surprise new joiners. First, audit events are strictly required if your change alters regulated state, like grades or permissions. Second, accessibility standards are mandatory on every single ticket, not just design tickets. Keyboard paths, contrast ratios, and labels have to be there. And lastly, no exceptions. You cannot selectively ignore the definition of done. If an item genuinely has to be deferred, you don't just leave a box optimistically unticked. You have to write a brand new follow-up ticket.
Section 5. Tooling and Guardrails. The Invisible Project Manager.
To keep 29 epics from devolving into total chaos, the system relies on 3 simple scripts, acting as an invisible project manager. The first is validate. Sure, it checks for typos and missing descriptions, but its real superpower is catching impossible planning errors. Like it once caught that a Phase 1 ticket was secretly relying on a Phase 5 well-being engine. It catches contradictions like that in seconds, way before a line of code is ever written. Then there's render, which deterministically generates the board document so it never silently drifts. And finally, sync, which mirrors the YAML tickets directly into GitHub issues.
And that brings us to the absolute golden rule of this system. The YAML wins, always. GitHub issues? That is merely a mirror for daily status and discussion. If you edit an issue body in GitHub and expect it to stick, think again. The YAML will mercilessly overwrite it on the very next sync. The ultimate definition of the work belongs strictly in the YAML.
By enforcing these strict rules and utilizing some really lightweight tooling, the system flawlessly handles scale. At the time of writing, this repository smoothly manages 227 tickets across 29 epics. To put that into perspective, that's roughly 807 engineer days of incredibly dense work, all kept perfectly consistent, version-controlled, and validated just by simple code scripts.
So, we arrive at our final thought for this explainer. If your plan is constantly drifting from reality, if your tracker feels more like a graveyard of outdated promises, maybe it's time to stop relying on external tools. Could your team's chaos actually be solved by bringing the backlog home to the repository and treating your project plan exactly like your code base? It's definitely a radical idea, but as SharpBrain shows us, it might just be the exact clarity your engineering team needs. Thank you so much for joining me for this explainer, and I hope this sparks some great conversations with your own team.